Okay, section 7.3 is on scientific notation, so hopefully most of this will be familiar to you if you remember scientific notation from middle school. Alright, it is a way to write very large and very small numbers, so numbers that would normally take up a lot of space because they have so many zeros. We use scientific notation as a way to write them shorter. So remember, it's going to be some number, alright, times 10 raised to a power. And remember, that number has to be between 1 and 10. It can be equal to 1. It cannot be equal to 10. So 1, 1.4, 3, 7.9, 9.99999, just something between 1 and 10. Okay, so first thing we're going to practice is changing numbers from standard form, so like they're normally written, into scientific notation. So remember, at the end of every large number there's a decimal point, and then I could add as many zeros out there as I wanted to. What we're going to do is take that decimal point and move it until it is to the left of the first non-zero digit. So if I look at this number, 2 is not a 0, so I want it to be right there. So that was actually filled in wrong. This should say to the right. I want it right to the right of the number 2. Alright, and then I need to count how many places that would move. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So to get the decimal place to be there, I will have moved 8 places. Okay, so now here's my new number. I don't need all of those zeros anymore. I have 2.01. Remember, that number has to be between 1 and 10. Well, 2 is between 1 and 10. Okay, so 2.01 times 10, and then it's going to be to the 8th power. I just have to decide if it should be positive or negative. In your notes you have, if you move to the left, which is what we did here, then the exponent is positive. The other thing is, positive exponents mean large numbers. So this number with all the zeros is 201 million. That's a lot. If that was money, you'd be very happy to have that much. So large numbers mean positive exponents. Alright, here's example 2. Now this time it's a small number, right? It's a decimal, 0.000, so it's less than a penny, because think about it, if we have a penny, it would be 0.01, so this is a very small number. Okay, but I'm going to do the same thing. I'm going to move it to the right of the first non-zero digit. So 5 is my first non-zero digit, so I'm going to go to the right of the number 5. So 1, 2, 3, 4, 5. So my new number is 5.1 times 10, and I moved 5 places to the right, so my exponent is negative 5. Okay, then we're going to go the opposite direction. So this time the number is written in scientific notation. It already has the times 10 to something. And we're going to put it in standard form. So we're going to go backwards. I know this 10 to the 9th part is going to go away. So I'm just going to look at the 6.32. And it says I'm going to move the decimal point the same number of times as the exponent. Alright. Positive numbers, you're going to move to the right. Negative exponents, you would move to the left. So I'm going to go to the right 9 times. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in each of these spaces, now that I've created, I'm going to fill it in with a 0. Okay, so here is my new number, 6, 3, 2, 0, 0, 0, 0, 0, 0, 0. And then when we write really large numbers, we usually put commas every 3 places to help us read them. So there is 6.32 times 10 to the 9th is 6,320,000,000. Alright, here's the second example. So this time I have 4, and it's to the negative 7, so I'm going to go to the left 7 places. So 1, 2, 3, 4, 5, 6, 7. Fill in each of these with zeros, and that's where my new decimal point would be. So point, and then I have 6 zeros, 4. 4 times 10 to the negative 7th is this number. Okay, then the last thing that we're going to do, which you may not have seen before, is we're actually going to multiply and divide numbers that are written in scientific notation. We're going to do it the same way that we did with the monomials that we were multiplying and dividing earlier. So the first thing I'm going to do is multiply or divide the constants. So if I look at this, I have 3.5 times 7. I'm going to do that multiplication first. Alright, 3.5 times 7 would be 24.5. Alright. Then we're going to multiply the tens, the scientific notation part, using the laws of exponents that we learned at the beginning. So 10 to the negative third times 10 to the sixth. Remember, we are going to do multiplying, so we're adding the exponents. Alright, so negative 3 plus 6 would be positive 3. So now I have 24.5 times 10 to the third. The problem with that is our answer has to be in scientific notation, and 24 is bigger than 10, which is the max for scientific notation. So what I actually need to do here is move this decimal place 1 to the left. So now I have 2.45. Alright, and since I moved it 1 to the left, I'm going to add a number to my exponent. So instead of 24.5 times 10 to the third, I'm going to make it 2.45 times 10 to the fourth. And then just real quick here, I'm going to show you that these are equivalent expressions just to make sure that we did it right. So if I have 24.5 times 10 to the third, alright, I get 24,500, and then we changed it so that's in scientific notation to 2.45 times 10 to the fourth, and we get the same number. So those these two expressions right here, 24.5 times 10 to the third and 2.45 times 10 to the fourth, they are the same, but this has to be the final answer because it needs to be in scientific notation. Alright, example 2, this time we have division, so we're going to do the same thing. We're going to divide the constants first. So 3.066 divided by 7.3, which gives me 0.42. Alright, and then 10 to the 8th divided by 10 to the third. Remember, when you divide, you're going to subtract the exponent, so that would be 10 to the 5th. Alright, again, this is not in scientific notation because 0.42 is less than 1, and remember, it has to be between 1 and 10. So I'm going to move 1 to the right this time, and my number becomes 4.2. Alright, since I moved to the right, I have to take a number away from the exponents that is there. So it's going to be 4.2 times 10 to the fourth power.